Hey guys, welcome to the NCEA Level 3 Calculus Integration exam paper from 2020. The way this video works is that I go through each one of the questions, tell you guys what you need to do for achieve merit and excellence. Best way to watch this video is to pause the video at the start of each question, try the question out by yourself, see how you go, and then check my answers just to see how far you actually went with the question. So without further ado, let's get started. So nice, always nice questions they start off with, shouldn't take you guys too long. So we've got x, we're going to integrate x, which gives us x squared over 2. 2 integrates to 2x, and of course 3 over x integrates to 3 ln of x. And of course, don't forget your plus c. Basically, this gets you an achieved, and that's question 1a. Moving on to question 1b. So with 1b, what we've got is we've got a velocity function, and they're literally asking to find the displacement function and then find out what the displacement is after 16 seconds. So this is what we have. We actually have v of t, which equals to 0.6 t to the power of half, and the question's actually asking s of 16. We also know that s of 0 is equal to 5. So those are just some useful things to remember. So we're going to integrate velocity to get displacement. So s of t is equal to 0.6 t to the power of half. Of course, we've got to add 1 to the power. And we've also got to divide by the new power, which is a half plus 1. And of course, don't forget the plus c. So s of t could be written as, I'm just going to simplify this 0.6 divided by 1.5, which is going to give me 0.6 over 1.5. So that's going to give me 0.4. So I've got 0.4 t to the power of half plus 1 is just 3 over 2. So 3 over 2 plus c. Now, we know that s of 0 is equal to 5. So we're going to put that here. S of 0 is equal to 5. So 5 is equal to 0.4. T is 0 plus c. And so because it's 0 to the power of 3 over 2 is just 0, so we can say that c is equal to 5. So what we've figured out is s of t. S of t is 0.4 t to the power of 3 over 2 plus 5. And now we need to figure out s of 16. So we got 0.4 multiplied by 16 to the power of 3 over 2 plus 5. And so putting that in the calculator, we've got 0.4 times 16 to the power of 3 over 2 is 1.5 plus 5, and that's going to give us 30.6. And the units, of course, it's going to be in centimeters. Now, as much as this question is so long compared to the first 1a, this is still just worth an achieved. So you need a correct solution with correct integration as well. Cool. So moving on to the next question. So with this question, it actually says that you have to show you have to use calculus to show the results of any integrations. And I guess the reason they ask you to show the integration is because you can actually put this straight up in the calculator, and I will show you guys how to do that. But we kind of need to what do we call it? We kind of need to integrate this first. Now, again, you might have a completely different way of doing this, which if you do, fantastic. I tend to kind of have a look at this and go, okay, so I need to use long division for this. And as I said to you guys before, like if you have a different method and it works for you, great. So I'm just going to multiply by 5, which means 5 times x is 5x. So I'm basically doing this. And then 5 times negative 3 is negative 15. Now I've got to subtract it. So 5x take away 5x is 0. Negative 11 take away negative 15 is going to be positive 4. So in other words, what I can do is I can rewrite 5x minus 11 divided by x minus 3 is equal to 5 plus the remainder, which is 4, over x minus 3. So I've literally rewritten that equation as integral of between 8 to 4 of 5 plus 4 over x minus 3 dx. Now I'm going to integrate this. So 5, when I integrate it, it's going to be 5x. And of course, when I integrate anything with x in the denominator, so it's going to end up looking like 4 ln of x take away 3. I don't need to worry about, well, I mean, I can just show you, like I still have to divide by the differentiation of whatever's inside here. And in this case, it's 1. So that's why I kind of like didn't really go too much into detail. I don't need to worry about the plus c because this is definite integrals and we're looking for between 8 and 4. So our next step is just substituting it. So we've got 5 times 8 plus 4 ln of 8 minus 3 minus 5 times 4 plus 4 ln of 4 minus 3. So, at this point, you can just chuck this in the calculator. And like I said to you guys, I'm going to show you guys both methods. So we've got 5 times 8 plus 4 ln of 8 minus 3, which is 5, minus, I'm going to put a double bracket, no, single bracket is fine, 20 plus, well, that's just going to be 0 because it's ln of 1. And as you guys can see, it's giving me an answer of 26.44. Now, what I would recommend you guys to kind of do is also check the answers. You can check it. So just click on option, go to calc, and there's an integral button right there. So you just put integral, open up a bracket, and you put down 5x minus 11. And that's divided by x minus 3. You put a comma, you put your lower limit, which is 4, and your upper limit, which is 8. Yeah, that's another way you can actually get that answer as well. So my recommendation is like, this line here, you might want to write this line down, but then rather than doing that in the calculator, like I would just do the integral version of it. So I get so even if I make a mistake in this line, I would still end up with like the right answer. Cool, so grades wise, you're looking at correct solution with correct integration is going to get you a merit. Correct integration gets you an achieved. So that's going to be not there. We're looking at here in this line, you're going to be getting an achieved for this. Okay, let's move on to the next question. Okay, so for question D, what we've got here is we've got two graphs and we're trying to find the shaded region. And I know that if you guys have been watching some of my tutorials, or even you might have done this, which is pretty normal, where they go the top function minus the bottom function to get the area between the two curves. I guess our first step that we've got to try and do is try and work out these 2 points here. Now, considering that this is an integration paper, you're not going to be, you theoretically should not be penalized if you just plug in the values into the calculator to get those intersection points. So, right now you need to figure out those 2 red points. And the way you're going to do that is you're going to go 4 equals x plus 3 over x. And of course, you got to rearrange this. So I'm going to multiply everything by x here. And when I multiply everything by x, I'm going to end up with 4x equals x squared plus 3. And if I rearrange this, I'm going to get 0 is equal to x squared minus 4x plus 3. And I've got a little quadratic right there, which is x minus 3, x minus 1. And so because if they're both equal to 0, then we can say that x minus 3 equals to 0, or x minus 1 equals to 0. And we're going to get our 2 values as x equals to 3 and x equals to 1. So basically, this is 1, and this value right here is 3. So how could you have done this in the graphics calculator? So in the graphics calculator, I would have just gone straight into graph right there, chucking up 4, and the other one was x plus 3 divided by x. And I'm going to click on draw. Obviously, I cannot see it right now, so I just need to change my view. So I'm just going to zoom out a little bit. Let's see. Okay, there you go. You can kind of see that's where the intersection is happening. So click on G-solve and look for intersection. There's your first point when x equals to 1 and y equals to 4. Click on the arrow, right arrow, and it gives you your second point, which is 3 and 4. So that's a really quick way to figure out where your 2 intersection points are. So theoretically, like, I wouldn't stress about showing the working of how you get to the 3 and 1. Cool. But however, for the area itself, we're going to need to use integration. So we're going to do the classic one, which is the two intervals. So in this case, it's 3 and 1. And we're going to go to the top function minus bottom. And basically, the top function is whatever's in the yellow there. That's your top function. And your bottom function is the blue line, which happens to be that other curve there. So if we're going to go top minus bottom, we're going to do 4 minus, and we've got x plus 3x, which we're going to put in a little bracket like this, and dx. So now it's just a matter of taking out the brackets, integrating it, and kind of solving it. So we're going to get 4 minus x minus 3 over x dx, and now I'm going to integrate it, which means I'm going to get 4x minus x squared over 2. What else have I got? Minus x squared over 2, and this is going to become 1 over x, so it's going to become 3 ln of x. And all of this is, of course, between 3 and 1. So I've got to substitute 3, so I've got 4 times 3 minus 3 squared over 2 minus 3 ln of 3, take away 4 times 1 minus 1 squared over 2 minus 3 ln of 1. Now, as I said to you guys before, you've got two options here. You can actually sit here punching this whole thing in your calculator and hope to God that you didn't actually make a little mistake. Otherwise, what I tend to do is, like in this scenario, go into the integral option. So basically go into options, calculus, integral, and I'm going to put in my, and this is important, like this time people forget it. It's like you don't actually put the integrated function, you put the original function. So I'm going to put it as 4 minus bracket x plus 3 over x. So that's my original equation. And then, of course, that's between 1 and 3. So the lower limit comes first, which is 1, 3 upper limit. And it gives me an answer of 0.704. And that's what I'm going to put down here. So even if I make a mistake in this line, like by putting something incorrect, it's kind of like safety proving your answer by doing it on the calculator, but at the same time, you're still showing the working. So grades wise, the final answer is going to get you a merit, correct solution with correct integration, and then correct integration of expression to find area gets you an achieved. So I'm thinking you probably need to do this to get an achieved. So finding those points literally mean nothing. You know, your first achieved grade really only comes in that third line of that working out there. So that's something to keep in mind with these types of questions. Okay, so let's go to the next one. All right, guys, so with this question, what we've got here is a lovely differential equation. And you know that if you've been watching some of my skills videos, that I always talk about bringing the y's to the left-hand side and taking all the x's to the right-hand side, and, you know, just go from there, just start working from there. So with this question, that's what we're going to do. So at the moment, we've got, what have we got? We've got tan x dy dx, and I think really we're just trying to find the value of y when x equals to pi over 3. So it's just going to be like solving the classic differential equation, right? We'll rearrange, get an equation, you'd have a c, use this information to actually find this information here to find what c is. Once you find c, substitute x to actually solve the question, which is to figure out what y is. So with that in mind, I am going to actually swap over the y and x. So this will become y dy dx equals sec squared x tan x, and of course I need to get rid of the dy to the other side as well, because sorry, not dy, dx. So this becomes y dy sec squared x over tan x dx. Now, something that's really worth kind of keeping an eye on is, like, when you see the sec squared x, right? So it's like really easy to kind of go, oh, I'm seeing sec squared x, that means sec squared is equal to 1 over cos squared. But then there's a tan there, which means tan could be written as sine over cos, and suddenly you're going to create like this really ugly looking thing. And I guess this is where it kind of gets really handy when you know your differentiations kind of like by heart. Like you know that when you, if y is equal to tan x, when you differentiate, you're going to get sec squared x. So basically what I'm trying to say here is you've got the differentiated function on top and you've got y at the bottom. And I know in one of my videos I talk about this, like when you have the differentiated function in the numerator, it straight away you can rewrite this as ln of y. Because remember that when we actually do ln of a function, we, like say for example, I do something like this, right? Ln of x squared would be like 1 over x squared multiplied by 2x, which is the differentiation of x squared. So that's what's happening in this little area here. So I'm going to integrate both sides, and when I integrate y, I'm going to get y squared over 2, which is then equal to ln of tan x plus c. All right, and I think that's the most kind of like the trickiest part in this particular question. And I think if you can get your head around that, you pretty much easy ride from this point onwards. Because the next step that we're going to do is we're going to use the part that's highlighted in yellow, which is x equals to pi over 4. Y is equal to 2. We're going to use that to figure out what c is. So we're going to get 2 squared over 2 equals ln of tan pi over 4 plus c. So going into my calculator, I'm going to work out what tan pi over 4 is first. Always a good idea to check that because I'm working in pi over 4, I want to make sure that my calculator is in radians mode, which is, that's good. So I've got tan of pi over 4, whatever that is. So that's equal to 1. So I know that I've got 2 squared over 2, which is 4 over 2, so that's going to be 2. And then ln of 1 plus c. Ln of 1 is equal to 0, so c is equal to 2, which means I have my equation, which is y squared over 2 equals ln of tan x plus 2. And again, now I'm trying to solve the part that's highlighted in blue, which is x is equal to pi over 3. What is y? So we've got y squared over 2 equals ln of tan pi over 3 plus 2. So going back to my calculator, and I need to work out what pi over 3, tan of pi over 3 is. So that is obviously looking like an ugly looking number, 1.73. But you know what, I'm going to leave it there like that because, and this is some of the tricks to make sure that your answers are as accurate as possible. So we're going to leave that 1.73 2 plus 2. So we're going to get y squared over 2 equals to 3.732. So let's actually go, no, I've just realized I made a mistake. That's not right. That should have been ln of 1.732 plus 2. So let's try that one again. So I'm gonna, this is what I mean by, like, I'm not going to get rid of that ln of, I'm not going to get rid of the 1.732. Instead, I'm just going to do ln of answer, and that's going to give me 0.549 plus 2. And of course, y squared over 2 equals to 2.549. So I'm going to add 2 here. So that's 2.549. Then I've got y squared equals to 2.549 multiplied by 2. So 2.549 multiplied by 2. So that's 5.098. And again, I've not really got rid of my answer from the calculator yet. I'm actually working with the calculator and on my paper as well. So now I can say that y is equal to square root of 5.098. So I'm going to chuck in the square root symbol in the calculator and of course use my answer function, which gives me y is equal to 2.258. And this is something that you guys need to know, this part right here. It is so important that you actually, anytime you deal with a square root number, you've got to actually think about putting plus or minus, because in this question, you will get 8 points if you put plus or minus, and if you forget the plus or minus and you just write it as 2.258, you're only going to end up getting 7 points for that question. All right, so it's really important that you guys put that plus or minus in there. So that's pretty much for this question here. So in terms of grades, I know I kind of went through the excellence grade first. For merit, you're looking at correct integration, which is somewhere here. Correct integration on either side with separation of variables is an achieved. So achieved is either getting one of this or this one correct. So it's like it's not a bad excellence question because it's a standard excellence question, if I may call it. Like if you have been doing differential equations before, you know that this type of question is pretty much what they ask. And if you can get that kind of like understanding behind it, so when you're starting out with the differential equation, bring all the y's to one side, bring the x's to the other side, integrate, solve for c, and substitute, and you're pretty much good to go. All right, guys, that's basically it for question 1. All right, guys, so we're going to question 2a at the moment. So question 2a is we've just got just a straightforward integral question. So we're going to write this as, I need to kind of rewrite that x squared first. Because it's x squared, I'm going to write it as pi minus 2x to the power of negative 2 dx. So when I integrate pi, I'm going to get pi x. And then here I'm going to get minus 2x negative 2 plus 1. And all of that is divided by the new power, which is negative 2 plus 1. And of course, don't forget the plus c as well. So simplifying this a little bit, I've got negative 2x to the power of negative 1 over negative 1. And again, like you could potentially leave the answer in that second line, but I'll probably just put like a little bracket there just to show what I've done there. So this answer ends up getting an achieved. As you can see, I've not actually gone beyond this question in terms of simplifying it. Like you could simplify it, but really this is, I don't see any issues with this one here. Okay, question 2b. God, I hate Simpson's rule. Why I hate Simpson's rule? It's because I just do. Let me just copy down the equation first, because by the way, guys, let me show you where the equation is. So Simpson's rules, just remember that like when you go into your formula sheet, it is going to be there. These two formulas are always there, and it is simply a matching game. That's all it is, right? You look at the integral, like, you know, you've got b and a. So if you go back to our question, like I'm going to copy that equation down, and I'm going to kind of just break it down real quickly to you guys. Yeah, it's just one of these questions where you're literally just substituting and putting it in a calculator to solve it. So let's see. Cool, so there is the formula that just gonna copy down real quickly. So we've got to figure out what h is first. So b is 3, 0 is a, and then n is the number of intervals we have. So that's 1, 2, 3, 4, 5, 6. That's equal to 6. And the next thing is also, this is your y0, y1, y2, y3, y4, y5, and y6. So basically your odds all get collected. Your odd y values get multiplied by 4, and your even y values get multiplied by 2. So we're literally just going to fill this all up, guys. So we've got 1/3 times h, which is 3 minus 0, 3 over 6. Then we've got y0, which is 1.1. Yn is basically the last value. So in this case, it's y6. That's 1.3. Plus 4 times 1.8 plus 2.4 plus 1.8. And then plus 2 times 2.1 plus 2.7. So as you can see, it is simply just putting it all in a calculator. So I've just done that quickly. 3 over 6 times 1/3 is 1 over 6. And now it's just putting this whole shebang. Like I'm not gonna lie, like I hate doing this question because like it just requires concentration for putting in all the correct values. It's so easy to make a mistake. And like, see, right now I'm trying to concentrate while trying to type this. It's it's just funny. Cool. So I've got 36, and 1/6 of 36 is just 6. For achieved, this is surprisingly quite a bit of work that you end up doing. But yeah, that's basically what it is for achieved. That's all you got to do. All right, guys, let's go to the next one. So question C here is what we've got is integrate. Oh, we've got a definite integral with k in 1, and we've got to try and figure out what the value of k is. So putting this out, I'm going to do this first. So k in 1, 9. I've got 3x minus 2 to the power of half is equal to 126. So integrating this, I'm going to get 9, 3x minus 2 to the power of half plus 1. And of course, divided by half plus 1. And I also got to divide by the differentiation of whatever's inside the bracket, which is 3x minus 2. So I've got to divide by 3 there as well. So that's pretty much my integration covered. And I know that the whole thing is between k and 1, and it is equal to 126. So now it's just a matter of simplifying that, simplifying everything so that I can actually kind of make sense of it. So I've got 9, 3x minus 2 to the power of 1.5 divided by 1.5 times 3, which is 4.5. And again, I'm just kind of like being super lazy. 9 divided by 4.5 is 2. So I've got 2, 3x minus 2 to the power of 1.5. And that's between k and 1, which equals to 126. So I've got 2 times 3k minus 2 to the power of 1.5 minus 2 times 3 times 1 minus 2 to the power of 1.5 equals 126. So 2 times 3k minus 2 to the power of 1.5. Now what's going to happen here? I've got 3 minus 3 times 1 is 3. 3 minus 2 is 1. And 1 to the power of 1.5 is 1. Negative 2 times 1 is just negative 2. And all of this is equal to 126. So I can rearrange this now. So I'm going to get 2, 3k minus 2, 1.5 equals 126 plus 2. That's 128. So far, so good. Get rid of the 2 to the other side. That means it's going to get divided by 2, which is 128 divided by 2. And I've got 3k minus 2 to the power of 1.5 equals 64. I should have actually written, instead of 1.5, as 3 over 2, because that actually helps me. So once we're at this step, folks, what we're going to do is we're going to try and figure out a way to get rid of that 3 over 2. So remember that 64 is actually has a power of 1 in it. So I'm going to multiply the powers on both sides by 2/3. And by doing this, I'm going to get rid of the power from 3k minus 2. Then I've got 64 to the power of 2/3. Now 64 to the power of 2/3, chucking it on the calculator, I'm looking at 16. Then I can rearrange this. I'm going to get 16 plus 2. So 3k equals to 18, and k is equal to 6. So grades-wise, you're looking at, for solving k, as 6 is merit, and achieved is right at the beginning there when you just integrate the original function. That's pretty much what we're looking at for achieved. Cool, guys. We are off to the next question. So looking at this next question, we've got another differential equation, just like how we did in question 1e. It's weird because it's pretty much the same question, similar type of question, and the only difference is you don't have that ln, but it's actually worth the merit. But let's have a go at this anyway. So we've got dy dx equals to square root of y times cos 4x. So I'm going to take dy over square root of y equals cos 4x dx. Now, square root of y could be written as well, I've got to do a couple of things, but y to the power of half equals cos 4x dx. And then I'm going to bring y to the power of half to the numerator to make it negative half equals cos 4x dx. Now I'm ready to integrate it. So when I integrate y to the power of negative half, I'm going to get y to the power of negative half plus 1 divided by negative half plus 1. That's the new power. And that's all equal to integration of cos is sine 4x. And of course, I've got to divide by the differentiation of whatever's inside the bracket, which in this case is 4. And also have to put in the plus c. So kind of working at this, I have y to the power of positive half divided by positive half equals sine 4x over 4 plus c. Now, as you said, as we did in the question 1e, we've got this yellow information here, which we're going to use to figure out what c is. And then we're going to use the value of y, find the value of y when x equals pi over 4 by using, once we figure out what c is. So because we've got x is equal to pi over 8 and y is equal to 1, I've got 1 to the power of half divided by half. Divided by half is the same thing as saying multiplied by 2, so I'm just going to rewrite that. Give me a second. So I've got 2 square root of y equals sine 4x over 4 plus c. So I've got 2 square root of 1 equals sine of 4 times pi over 8 over 4 plus c. So I'm going to get 2 is equal to, now sine of pi over 2. I mean, I could do 4 pi over 8, same thing, so 1. So it's a quarter plus c. So I can say that c is equal to 2 minus a quarter, so c is equal to 1.75. So coming back to this, I've got 2 times square root of y equals sine 4x over 4 plus 1.75. Now the question is saying x is equal to pi over 4. What is y? So 2 square root of y equals sine 4 pi over 4 plus c. So I've got a sine of pi, which is going to be equal to 0. So basically, c, I've already got c, it's 1.75. So I've got 2 root y equals equals 1.75. So then square root of y is equal to 1.75 over 2. 1.75 over 2. What can I write that as? 7 over 8. So square root of y is equal to 7 over 8. And then y is equal to 7 over 8 squared, which gives us 49 over 64. So grades wise, we are looking at the final answer, which is 49 over 64 as a merit. Correct integration of either side gets you an achieved. So that is going to be either this or this to get an achieved. So as you can see, it's pretty much the same amount of working as what we did for question 1e. But yeah, the only difference between 1e and 2d is that the integration of that function that we did, which was at sec squared over 10x, which was a little bit more trickier. But I think otherwise it's pretty much exactly the same two types of question. All right, guys, so let's go to question 1e. So question 1e is pretty much another similar question that we did earlier with finding area between two curves. I guess the first step we've got to do is we've actually got to work out what that value there is. And I think once we figure out that value, we should be able to kind of work out this question. Now again, what you could do is, you've got y is equal to 0. So you've got 0 is equal to x plus 2 root x minus 3. I know that in level 2 algebra, you kind of did these types of questions, but again, think about it like this. Like this is integration paper, and so really, I don't see why there would be an issue for you to actually put this straight into the calculator just to get that red point. So what do I mean by that? Go into graph. Let's get rid of the other functions. And I'm going to go into x plus 2 root x minus 3. So when I draw that, that's the graph I'm looking at. I'm going to click on gsolve, and I'm going to look for the root because that's where it is going to cut the x-axis. And as you can see, that point right there is 1. So this red point right now is equal to 1. Now, if you want to actually know how to do this, you're like, actually, no, I also want to know how to do this. Then looking at this, this is square root of x. So this is the one where you do the u substitution. So you go u is equal to square root of x, and then u squared is equal to x. So 0 is equal to u squared plus 2u minus 3. 0 is equal to u plus 3 and u minus 1. So 0 is equal to, so you're going to get u plus 3 equals to 0, or u minus 1 equals to 0. So your first u value is negative 3, and your second one is positive 1. So we could kind of say square root of x equals negative 3, or square root of x equals to 1. Now square root of x equals negative 3, we're going to go into complex numbers territory, so we're not going to bother with that, or x is equal to positive 1. So that's that working out that you kind of need to, if you want to do it. But like I, again, kind of will challenge, because it's an integration paper, you can just get the x values for the graph from the graphics calculator and get on with actually answering the question. So our range, like kind of like looking at this equation, we've got it between 1 and 0. So x plus 2, x to the power of half minus 3, plus between 4 and 1, x plus 2x to the power of half minus 3. Basically, that's pretty much it, because we've got two areas, separate areas, and we just got to integrate it, substitute those values, and actually figure it out. So we're going to get, I'm going to do the first one here. I've got x squared plus 2x to the power of half plus 1 is 1.5, divided by 1.5, that's got to be x squared over 2, minus 3x, and that's between 1 and 0. Then I've got plus, same equation, right? X squared over 2 plus 2x 1.5 over 1.5 minus 3x, and that's between 4 and 1. Now there's one other thing that you guys need to remember. Remember that this area is going to come out as negative. All right, so what we want to make sure is we want to actually put a line here to say that it's actually the absolute value. And that's just something that you need to remember. Otherwise, it's going to, like, you're going to get a negative value, and then, yeah, you don't really want that. Okay, so the next thing is substituting all your values in here. So we're going to get the absolute value. So first I've got 1 squared, which is 1 over 2, plus 1 to the power of 1.5 is just 1, minus 3, so that's for all of it for 1, minus 0, so that's going to be 0 squared over 2, which is 0, 0, 0, yeah, that's just going to be 0. I don't really need to worry about it as much. That's the absolute value, plus I've got now 4 squared over 2, plus 2 times 4 to the power of 1.5 over 1.5, minus 3 times 4, and of course I've got to subtract all the 1's from there, so that's going to be 1 squared over 2 plus 2 over 1.5 minus 3. Now interestingly enough, this value here, let's just see what happens. Give me 1 second. So whatever that value that we're going to get in the yellow highlighted area is also going to be the same as this. So just to kind of like keep that in mind, So we're going to kind of work that out first. Let's clear that out and just try it out again. So we've got a half plus 2 over 1.5. Terrible use of decimals, but you know what, who cares? Minus 3, it gives me that. So that's negative 7 over 6. So what I've got here is absolute value of negative 7 over 6, minus 0, don't care, plus, I've got a minus. This is also equal to negative 7 over 6. So now I need to do the inside of that 4 squared over 2 part. So I'm going to do that, and what I've got, 4 squared over 2 by 2 plus 2 times 4 to the power of 1.5 divided by 1.5 minus 12 gives me that, which is the same thing as 20 over 3. So I've got negative 7 over 6, which is the absolute value of that is going to be positive 7 over 6, plus 20 over 3, and then negative times negative 7 over 6 is, again, 7 over 6. So I've got 20 over 3 plus 2 times 7 over 6, and that gives me a final answer of 9. Now, remember how I told you guys you could check your answers? Like, see, I would, let me just say correct solution, correct use of signed area. So I would probably show up to the second line. I might even show up to the third line, but then instead of spending all that time on trying to work it out, I would have just put straight up this on the calculator, right? Because me being lazy. So I'm going to go to integral. What have I got? I've got x plus 2 root x minus 3. So that's between 0 and 1. So 0 and 1 equals to that. Now that's actually, so this is negative, right? So I've got to take the absolute value of that. So I'm actually going to multiply it by negative 1 to make it into a positive value. Then I'm going to add that with integral of the same thing, which is x plus 2 root x minus 3, and that's between 1 and 4. Yeah, put that together, there's my answer of 9. So what I would have done is I would probably just do a bit of a sneak thing. I mean, this is just another way of you to check your answer, but I probably wouldn't have wasted my time doing that negative 7 over 6 plus 20 over 3, all that stuff. I would just go straight into there. Grades wise, correct solution with correct integral, correct use of signed area gets you an excellence. Merit is no solution, like maybe up to here, and achieved is integration of the expression itself. So I'll show you guys the answers to do, right? Like, so if you have a look at it, they don't, even at the beginning, they don't actually give you any grades for like finding those, where is it? They don't actually give you any grades for like finding the x values. It's just the integration of expression, which happens around from here to here. All right, so in fact, it's only like this line right here that you're going to get an achieved first. Yeah, so go guys, that's basically it for this question here. I think that's question 2. We move on to question 3. If I can find it, sec 2x tan x is, there we go, there's sec x tan x. So when we integrate sec x tan x, we're going to get sec x. So that means the integration of this is just going to be sec 2x. And of course, we got to divide by the differentiation of whatever this inside this little bracket is, which is 2x. So differentiation of that is just 2. And of course, don't forget your plus c. That is all for this question. Gets you achieved, and we literally just move on to the next question. Okay, so the second question, what we have got here is yet another differential equation. No, well, don't really have a differential equation, it's just integration. So we're going to integrate cos 2x to give it what y is. Integration of cos is sine. So that's going to be sine 2x divided by 2, because that's the differentiation of 2x. And of course, plus c. Next, we've got x is equal to pi over 12 and y is equal to 1. So we're going to use that to figure out what c is, over 2 plus c. So sine of pi over 6 that ends up being 0.5. So we've got 0.5 over 2 plus c. So we've got 1 equals 0.25 plus c, and c is equal to 0.75. So our equation is y is equal to sine 2x over 2 plus 0.75, and we've got x equals to pi over 4. What is y? So y is equal to sine of 2 times pi over 4 divided by 2 plus 0.75. So chuck this straight in the calculator. We've got sine of pi over 2, because 2 pi over 4 is pi over 2. It's going to give us that, divided by 2, and plus 0.75. There we go, 1.25 is our answer. And again, correct solution with correct integration gets you an achieved. A lot of work for an achieved question, but hey, welcome to NCEA Level 3 Calculus. Cool. So next question is we got kinematics. Look at this question. All right. So what we have for this question is we've got an acceleration formula here. So acceleration is t plus e 0.2t. Velocity of t is 8. So v of 0 is equal to 8. And the question is asking what is v of 10. Okay, so we integrate acceleration to get velocity. So if acceleration is t plus e to the power of 0.2t, integrating that, we're going to get v is equal to t squared over 2, plus we're going to write down exponential function as it is, but we've got to divide by the power, divide by the differentiation of the power of e. So in this case, it's going to be 0.2. And of course, don't forget the plus c part. Now 1 divided by 0.2 is the same thing as saying 5. So I just want to write it up a little bit cleaner there. So 5. So velocity function can be written as t squared over 2 plus 5 e to the power of 0.2t plus c. Now we're going to use this little information here to figure out what c is. Little distraction, it's all right. Where were we? So we've got to do v of 0 is equal to 8, and we're going to try and figure out what c is. So we're going to say 8 is equal to 0 squared over 2 plus 5 times e to the power of 0.2 times 0 plus c. So we're going to get 8 is equal to 0 plus e to the power of 0 is 1, 5 plus c. So we can say that c is equal to 3. So now that we've got c equals to 3, and our velocity function is t squared over 2 plus 5e 0.2t plus 3, we're going to substitute 10 as t, so we're going to get 10 squared over 2 plus 5e 0.2 times 10 plus 3, and we're going to check this all in the calculator. So we've got 100 divided by 2, or 50, come on man, you can just do that straight away. 5 of e to the power of 0.2 times 10 and plus 3. So all of that gives us 89.95. So the velocity that we're looking for is 89.95 meters per second, is it? Yep, meters per second. So grades wise, correct solution with correct integration gets you a merit. Correct integration is probably somewhere here. That's going to get you an achieved. Cool, let's go to the next question. All right, folks, another classic differential equation question. Most schools repeat that question because it's pretty much the same thing, and especially with the half-life questions, right? So how do we go about this? The only thing that we know is that we've got this some sort of manganese. Yeah. Okay. So half-life is 5.6 days. Basically, that means whatever A is, you're going to get A over 2. A is like the original amount that you have. A over 2, or like half, it takes 5.6 days to get to A divided by 2. Whatever, yeah. That's pretty much the idea behind it. But anyway, let's have a look at this. So we got a differential equation, which is dn over dt equals kn. So swap the elements around. So we're going to get dn of n equals k dt. Then we're going to integrate both sides. So this one is, because it's 1 over n, it's going to become ln of n equals kt plus c. And then we can write that n is equal to e of kt plus c. This is a standard bread and butter type question, and that's what I mean by it. So you're going to end up with this. And of course, e to the power of c can be separated, and that e to the power of c can be written as a. So that's like your original value there. So that is pretty much our first equation, right? Now, and I guess this is what I meant by, like, we don't know what the how much amount we have, but we know that 50% of the amount is going to disappear after 5.6 days. So, and that's what I meant by when I did this A over 2 and 5.6 idea behind it. So basically, it's to think about it like this. When t and a, if I put it like this, when t is equal to 0, let's actually put n as the, what is n? Is it the number of radioactive atoms. So whatever a is, that's when t is equal to 0, the number of atoms we have is a. But when t is equal to 5.6, the number of atoms we have is actually a over 2. We don't know how many atoms we started out in the original question. Like, we don't know how much it is. So that's why we leave it as a and a over 2. So based on that, I can actually rewrite this equation as a over 2 equals aek times 5.6. And I hope that kind of makes sense, because all I've done here is I've taken t is equal to 5.6, and if t is equal to 5.6, then n is equal to a over 2. And basically by doing this, I'm now going to be able to get rid of that a, because I'm going to get a over 2 divided by a equals e to the power of 5.6k. Now a divided by 2a is 0.5 equals e to the power of 5.6k. And then I can say that 5.6k equals ln of 0.5, and k is equal to ln of 0.5 divided by 5.6. So when I do that, ln of 0.5 divided by 5.6, and this is going to give me a k value of negative whatever that is, negative 0.123. You know what, let's go with 3. So my equation for the number of atoms is equal to AE. K is negative 0.1238 T. So this is the equation now. Now, if I go back to the question's actually asking me how long will it take for 95% of the manganese to decay, right? So if 95% is actually gone, then only 5% is actually remaining. So in other words, I'm trying to figure out when is 5% of A remaining there. That's what I'm trying to do, because A is the original amount that I started with, and I want to know when is 5% of it's going to remain, because 5% remaining means 95% is actually gone. So I'm going to go back here, and I'm going to replace n with 0.05a equals AE negative 0.1238t, and I'm going to get rid of that a now, because I'm dividing by a, which is going to be negative 0.1238t. The two a's cancel out, and I've got 0.05 equals E 1238t, and I've got ln of 0.05 equals 0.1238t, and t is equal to ln of 0.05 divided by negative 0.1238. So we're going to kind of just quickly work that in the calculator. I already have that in the answer section there, so that's why I don't actually delete my thing. So I'm just going to divide by answer, and that's going to give me 24.2 days. So this is like, I call this the cookie cutter kind of question, because it's like there's nothing much really that's happening apart from, you're going to get the standard differential equation, you integrate it, you find out what the k value is. Once you find out what the k value is, then it's like figuring out the question, figuring out whatever they're trying to ask in the question. So grades wise, correct solution with general solution, D, blah, 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 that's going to get you a merit. So basically you do need to show the full working out and the final answer. For achieved general solution of DE, clearly shown with two constants. Somewhere here, I guess. General solution of G with two constants. Yeah, it could potentially be there. Yeah, so, and I know like a couple of years ago I saw this question as an excellence question, but they had a little bit more to it. But in this case, it's just that, yeah, I guess that's why it's a merit question. All right, cool. Let's go to the last question. Okay, so the last question is we've got another shaded region question. This time they're kind enough to give us the points that we're looking for. And so we're simply going to do top minus bottom for this. That's pretty much all. So top minus bottom means we've got between pi over 2 and 0. We're going to go top, which is cos x, minus bottom, which is cos cube x dx. Okay, so yeah, I hope I didn't confuse you guys too much. I just did that top, which is that, minus bottom, which is this part right here. So once we get to this here, we just got to solve this and figure out what the shaded region is. Now, looking at this, you guys, I've seen people make mistakes with cos cube x. They write it as cos x to the power of 3 and plus 1 and silly things like that. Remember, there's actually two functions here. You've got a cubic function and you've got a cos function. So what I want to do is I'm going to take cos x out as a common factor. Because when I take cos x out as a common factor, I am going to end up with 1 minus cos squared x dx. So once we do the 1 minus cos squared x, we've actually got to go into our formula sheet to replace cos squared x. Where is it? There it is. So if I go into my formula sheet, so if you guys have a look here, cos squared theta plus sine squared theta equals 1. We're going to use that identity to get rid of the cos squared x. So we're going to come back here. And so we're going to rewrite this as pi over 2, 0, cos x, sine squared x, dx. Okay, now that we've got the sine squared x, you can kind of see you've got cos x and sine x there, which kind of like, they both, cos x is actually differentiation of sine x. And I guess this is where you go, well, how do I want to approach this, right? So you could use substitution, and some of you might see it straight away that it's just sine cube x over 3. And if you see that straight away, yeah, great, go for it. But unlike some people might not be able to see that straight away, and that's all right. So what we're going to do is you're going to put down u is equal to sine x, which means u squared is equal to sine squared x. Now du over dx is equal to cos x, and du is equal to cos x dx. Now I'm going to put that there, but I'm going to rearrange this in a slightly different way so that it'll actually make sense to you guys. Sine squared x, and then cos x dx. Because what I'm going to do right now is I'm going to substitute this with u. Now you could also do it with the values itself, like pi over 2 and 0. So you could actually do that as well to make things easy for you. So you could go u is equal to, if I have sine pi over 2, that's going to be sine of 3 over 2 is going to be 1. A little bit of a blank. Yep, that is 1. And then I've got sine of 0 is just equal to 0. So I'm literally going to rewrite this entire thing now as 1, 0. The 1 is, to have a whole bunch of highlighters now. So the 1 is actually from here. So what I've literally done is I've changed the pi over 2 to 1. Then I've put in sine 0 of 0 as here. So I've replaced the 0 with the next 0. Next, I'm going to replace sine squared x with u squared. And then I'm going to replace the entire cos x dx with du. And there is a lovely looking equation, which is like super simple, which I can integrate u squared. When I integrate it, I'm going to get u3 over 3. And this is between 1 and 0. Then I've got 1 to the power of 3 over 3 minus 0 to the power of 3 over 3, which equals 1/3. And yeah, that's basically it for this answer, because I'm trying to think. Yeah, no, I just checked the answer schedule. That is correct. 1/3 is the correct answer. But yeah, this is just basically using substitution to make things a whole lot easier for you in terms of solving this question. So grades wise, correct solution with correct integral gets you an excellence or 8 points. Correct integral is going to get you a merit. So about, actually that's not even there. I'm not even done the integral there. I guess I've kind of done my integral right here. Is going to get me a merit for that, because I guess I'm going to get a merit because I have to do all of these steps to get to this part here. There is no achieved for this question, guys. Unfortunately, it's just merit and excellence. All right, guys. That is the end of question 3. Yeah, overall, the paper I don't find it too challenging. I think, you know, I know compared to, like, I have to say, compared to tables, equations, and graphs from 2020, this integration paper is actually a bit of a walk in the park. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.